Hello everyone. So in this video we are going to discuss how to calculate the number of functions. So here we will discuss total number of functions, how to calculate one, many one, onto and into function from some set A to set B. So let's start. So the concept we will discuss through the questions again. The question here is, let's say we have two sets, set A and set B, and we are defining the functions from set A to set B. And how many total number of functions, one, many one, onto and into functions are there from set A to set B under different conditions. Okay. So now let's say the first case is you have number of elements in set A is equal to, let's say, 3, and number of elements in set B, this is also equal to 3. That means the number of elements in both the set A and B are same. Okay, so I'll give you the formula also, but again I recommend you to understand the logic here. Okay, then you can just apply the formula also, but idea is you have to understand how you are getting these formula. Okay, so let's say you are defining this function from set A to B. F is function from A to B. So the first question is, how many total number of functions are from set A to set B? So you can see total number of functions. Total number of functions. So how many total number of functions are there from set A to set B? So you can clearly see the first element, let's say this is set A, the first element is 1. So this is the first element. In how many ways you can map this? In how many ways you can have image of 1 in the set B? In 3 ways. Either you can have 1 mapped to 1, or it may be mapped to 2, or it may be mapped to 3. Now same logic, in how many ways you can map 2? So again you can have 3 ways, right? So this is 3, and into, again similarly for 3 you have 3 ways. So total number of functions is what? 3 raised to 3, which is equal to 27. So total number of functions from set A to set B is 27. Okay, now if I ask you how many of them are 1 functions, how many are 1 functions, 1 that is injective functions, how many are injective functions? Now what is injective function? That we have already done. So I'm assuming that you know the concepts of 1, many one, onto and into function, right? So now you see, for 1 function, every element of set A should have different image. So these 3 elements are there. In how many ways you can map these 3 elements of set A to these 3 elements of set B, such that every element is mapped to different element. So can we say there are 3 objects 1, 2, 3, and you have to place them on these 3 places 1, 2, 3. Correct? In how many ways? You can clearly see this is 3 factorial ways, because you can arrange them on 3 places in 3 factorial ways. So what is this? Total number of functions, 1 functions will be equal to 6. So from this you can say what are the many 1 functions, number of many 1 functions. So now what are the many 1 functions? You can clearly see what are many 1 functions. If the function total number of functions was 27, now out of these we have 6 1 functions. So obviously the remaining will be many 1 functions. So can we say this is 27 minus 6, that is equal to 21. These are many 1 functions. So we have got 1 function also, many 1 function also. Now let's take the fourth case, that how many of these functions are onto functions. So total 27 functions were there. Now the question is how many of them are onto functions. So the question is onto function. Now how will you get onto function? What is the meaning of onto function? There should not be any element in set B which is there which is not having any pre-image in set A. That means every element of set B should have some relation in set A. So now you see there are, number of elements in set A and set B are same. So obviously if you want to consume these 3 elements, then 1 element has to go to every element of set A. Correct? So can we say in how many ways this 1 can be mapped? Again only 1 way, right? 3 ways. Similarly 2 can be mapped in again. Similarly 3 can be mapped in how many ways? So can we say the total number of onto functions will again be 3 factorial, because ultimately you cannot have two elements mapped to only two elements mapped to 3 elements here, right? We cannot have this kind of relation 1 2 3 and this is 1 2 3. We cannot have this kind of scenario, because this will not be a onto function, this will be an into function, correct? So number of elements here are same, then you can say this is 3 factorial, which is again 6. So total number of onto functions you have, that is total number of into functions, you can again say total number of into functions will be what? This will be equal to 21, because if the function is onto, total number of functions is onto 6, then total number of into functions will be total minus this onto function, the remaining functions will be into function. So that will why this is 21. So you can clearly see if number of elements in set A and set B are equal. Let's say the number of elements in set A is m and number of elements in set B is also m. The total number of functions will be m raised to n. Total number of functions. Total number of one functions will be m factorial. You can see the logic here. Total number of many one functions obviously will be m raised to m minus m factorial. Total number of onto functions will be again m factorial. Total number of into functions will be m raised to m minus m factorial. So again, these are just the formulae which are derived by using the same concepts. Okay. So now let's try the second case. Now the second case says, let's say you have number of elements in set A. Let's say number of elements in set A is 5 and number of elements in set B is equal to 3. Let's consider this, that number of elements in the first set A is more than number of elements in set B. So you can see, let's say you have this case, this is set A, this is set B, and now we have some elements, let's say 1 2 3 4 and 5, and here let's say you have 3 elements A B C. Now the first question is, you are defining functions from set A to set B. F is defined from set A to set B, right? Now you see total number of functions. So I'll just write in short, total number of functions. Total number of functions. So again, how many total number of functions you can see defined from A to B? The first element can be mapped in how many ways? 3 ways. Either it can go to A, it can go to B, or it can go to C. This is 3 ways. In how many ways? The second element can be mapped again 3 ways. Similarly, third, fourth, and fifth. So these elements A 1 2 3 4 5 can be mapped in how many ways? 3 to 3 to 3 ways. So this is equal to 3 raised to 5 ways. Correct? You can just simplify this. Now the second part. How many 1 functions are there? Total number of 1 functions. 1 functions. Now see, if I map 1, in how many ways you can map 1? In any of this A, B, C. Let's say if I have this A 1, right? 1 is mapped to A. Now let's say second is mapped to B and third is mapped to C. Now we have to find the total number of 1 functions. So think about this. How many total number of 1 functions will be there? So now you see the fourth and fifth options. The fourth element, this fourth and fifth, do not have any element left in B, because if you map 4 to any of these elements, this will become a many 1 function. That means you can say total number of 1 function will be 0. That means all the functions will be what? All the functions will be, you can say, many 1 functions. So total number of many 1 functions will be 3:5. So you can clearly see, because the number of elements in set B, because we don't have any 1 function, because there are less number of elements in set B. So you cannot map every element with a different element of set B. Correct? That is why there is no 1 function. Now let's take the next case, that is onto function. Now how will you get, or how many onto functions are there from set A to set B? So here you have to remember one concept from permutation combination. So this concept you must have done in permutation combination. There is one formula. I'll just explain the concept part first, then I'll give you the formula. So here it goes. It's like this. Let's say you have elements in set A, that is 1, 2, 3, 4, 5. Now we want some onto function. Now what is the onto function? Onto function, that means every element A, B, C, every element of set B should have at least one relation in set A. So you can see, can we say this is simply saying, let's say you have 5 objects or 5 books you have, or 5 coins you have, 5 different objects you have, and you have to distribute them in among 3 persons. What are the persons? You can say A, B, C, such that every person get at least one object, such that every person gets at least one object. So it is like saying you have 5 different objects and you have to place them, or you have to give them, you have to put them among 3, distribute among 3 persons, such that every person get at least one object. So how to approach this? You must have done this in the permutation and combination. So the formula for this, that if I'll just write this, to total number of onto functions will be equal to sigma r is equal to 0 to n. I'll just explain what is r, what is n. This is minus 1 raised to r, this is ncr, this is n minus k, n minus r raised to m. Now what are n and m? The number of element in set A, this is equal to m, and number of element in set B is equal to n, where m, you can see where m is greater than n. So this is the formula which you have to apply for finding the total number of onto function when m is greater than n. This is actually the number of ways in which you can distribute m different objects among n persons, such that every person get at least one object. So this is from permutation combination. Okay, so now for example in this question you can see we have m is equal to 5 and n is equal to m is equal to 5 and n is equal to 3. If you want me to explain this formula also, you can just comment on the section chat box, and I can definitely explain you how you get this formula also. Okay, so now this is, if I put all these values, this is r is equal to 0 to 3, this is minus 1 raised to r, n, that is 3cr, what is n? This is 3 minus r raised to m, m is equal to 5. So if I just substitute this, r is equal to 0, you can see this is equal to minus 1 raised to 0, that is 1, 3c0, this is 3 raised to 5, minus, what is this? R equal to 1, this is minus 1, this is minus 1, 3c1, right? This is 3c1, 2 raised to 5, r equal to 1, we have put r equal to 1. Then if I put r equal to 2, this will become 3c2, this is 3c2, minus 1 raised to 2 is 1, and this is 3 minus 2, that is 1, 1 raised to 5. And if I put the last term, that is r equal to 3, that will be 0, so that is, you can just leave that now. So this is, you can see 3 raised to 5, 3 raised to 5, this is 9 into 9 into 3, this is 81 into 3, that is 243, right? This is 243 minus, this is 3 into 2 raised to 5, which is 32, and this is 3c2 is equal to 2. So what is this? This is 246 minus 690, this is 96, right? So if I just subtract this, this is, you can see 150. Okay, so total number of onto functions from set A to set B is equal to 150. So this is 243. Among 243, the total number of onto functions is 150. So now what are number of into functions? Into functions, total number of into functions will be, the functions which are not onto will be into. So that is why this is 243 minus 150. So this is equal to, you can say this is 3 and this is 9, right? So this is the 93 functions which are into functions, right? So I hope this point is clear. So yes, let's now move to the next question. Yes, so now we have taken two cases. The number of elements in both the sets are equal. Set A has more elements in set B. Now the third case, let's say the number of elements in set A is 3 and number of elements in set B is equal to 5. Now the question is again, let's say you have this, let's say this is set A, this is set B, and we are defining functions from set A to set B. Let's say this is number of elements set A is, let's say A, B, C, 3 elements, and B has 5 elements, 1, 2, 3, 4 and 5. Now the question is how many total number of functions. The first part, now we can just try this total number of functions. So how many total number of functions? Again, the first element can be mapped in how many ways? 5 ways. The second can be mapped in 5 ways and third can be mapped in 5 ways. So this is 5 raised to 3. Now second, total number of 1 functions. 1 functions. So now if I have total number of 1 function, which you have to find total number of 1 function. Now you can see if you have 3 elements here, maximum how many elements you can take from B. If every element is mapped to different elements, for example, A is mapped to 1, B is mapped to 2, and C is mapped to 3. This is one function, right? So basically, how many maximum elements you can consume? Only 3. So can we say total number of 1 function will be, you select any 3 elements among this. So this is 5C3. You can take any 3 elements from this. And in how many ways you can, for example, I have selected 1, 2, 3. In how many ways now you can map A, B, C on these A1, 2, 3, or in how many ways you can arrange A, B, C on this 1, 2, 3. 3 factorial ways, right? So what is total number of 1 function? This is 5C3 is 10 into 6, which is equal to 60. And what is this? This is 120. Now, so total number of many 1 functions. Now the functions which are not 1 will be many 1 functions. So total 125 were there, out of which 60 are 1 function. That is why this is 65 are many 1 functions. Similarly, now we want to find the onto function, total number of onto functions. Now how many onto functions are there? Again, now this is a tricky part. First you think about this, what is an onto function? So if you want to find onto function, number of onto functions, maximum how many elements you can map here? If I map these A, B, C to different elements also, you can maximum you can consume 3 elements from this. So in any case, you will have at least 2 elements which are remaining here. At least 2 elements will be remaining because maximum you can combine 3 elements. That means there is no onto function because there will be at least 1 element in set B which will not be mapped to set A, right? So that is why total number of onto functions will be 0 and total number of into functions, you can say into functions, is equal to 125. That is all the functions are into functions. So this is a simple logic of getting the total number of 1 many 1 onto and into function. This part is easy, I think, because it's a straightforward question where you have to find the number of 1 onto, many 1 into, where number of elements in set A is less than number of elements in set B, right? Now the problem generally comes in this case. So I hope you just understood this part, because you have to apply the total number of onto function. The formula for this is given to you. Okay, so this is, I'll just explain it again. This is R equal to 0 to n minus 1 raised to r NCR n minus r raised to m. This is total number of onto function from set A to B, where set A has more element in from the set element of set B. Okay, in that case only this is applicable. Otherwise you will not apply this. In other case, you can clearly see the total number of onto function is 0, right? So you can just think about this logically also, right? So let's take one more question. This is the general question. The question here is the number of maps, the number of functions from set A to B. Set A, which is 1, 2, 3, into set B 1, 2, 3, 4, 5, 6, 7, such that f of I is less than equal to f of j, where whenever I is less than j. You have to map function from A to B such that f of I less than equal to j whenever I is less than j. That means if I say I is less than j, if I take any two values I and j, then the value at x equal to I should be less than or equal to the value at less than j. Correct? So let's give it a try. So the question here is, you have to define the function from set A to B. Let's say this is function f defined from A to B, and A has 1, 2, 3 element, and B has 1, 2, 3, 4, 5, 6 and 7 elements. Okay, now you see the condition is, if I, let's say if I take f of 1, f of 2 and f of 3, right? X is equal to 1, x is equal to 2, x is equal to 3. So f of 1 should be less than equal to f of 2, and this should also be less than equal to f of 3. This is the condition, because whenever I is less than j, that means the value at x equal to 1 should be less than equal to less than equal to value at x equal to 2, less than equal to value at less than value at x equal to 3. Correct? So now see, if you are mapping from set A to set B, the range, that how many elements can be taken from set B. Either all the elements are mapped to 1. For example, consider this case, all the elements are mapped to one element only. It may be any element. I am just giving you that range has only one element. Or we can have a case where all the elements are mapped to only 2 elements of set B. That means range has 2 elements. For example, if I map 1 with 3, this is another case I am discussing, 4, and let's say 3 is mapped to 4. That means range has 2 elements. You can see 3 and 4. And there can be third case that all the elements 1, 2, 3 are mapped to 3 elements of this. So if you take these 3 cases, then under this condition total number of functions will be 1. So let's start then. So let's take the first case, that range of fx you can say has only one element. So what is the meaning of this? That means you can see, let's say this is 1, 2, 3. Here we have 1, 2, 3, 4, 5, 6, 7. So if a range has only one element, that means all these values 1, 2, 3 or 1, 2, 3 will be mapped to only one element. So you can see, even if you take any value, for example, if you take 2, 1 is mapped to 2, 2 is mapped to 2, 3 is mapped to 2. This condition f of I is less than equal to f of j is satisfied here, because f of I is equal to f of j here, because f of 1 is equal to 2, f of 2 is equal to 3, 2, f of 3 is also equal to 2. So this condition is satisfied in this case. So in total number of these type of functions where range has only one element. So in how many ways you can select one element out of these 7? So there will be 7C1 ways, or you can say 7 ways. So there will be 7 functions of this type where we have range equal to one element. Range has only one element. Now if you take the second case, that range of f has 2 elements. Now what is the meaning of this? That means this 1, 2, 3 will be mapped to 1, 2, 3, 4, 5, 6, 7. This is 1, 2, 3. Now in this case, you see, we have to select 2 elements out of this, right? So in how many ways you can select 2 elements? 7, C2. So for example, let's say I have selected, simple case, I have selected 1 and 2 because we want 2 elements in the range. Now we are trying to map under this condition. So can we say, if you are selecting any 2 element here, I have taken 1 and 2. Obviously, the 1 will be mapped to the smaller value in any case, and 3 will be mapped to the larger value. because we want f of 1 should be less than equal to f of 2 should be less than equal to f of 3. This is the basic condition which we have to follow according to the question, right? So now you see, if I say f of 1 is less than f of 1 is equal to 1, f of 3 is equal to 2, for example, in this case. Now 2 has how many options? 2 has two options. Either it can be mapped to 1 or it can be mapped to 2, any one of them. So that means in how many ways you can map this 1, 2, 3 under this condition? You can say only 2 ways. Why? Because 1 definitely will go to 1 and 3 will definitely go to 2. And we have only option left for 2. There will be 2 options, that is it can go to 1, it can go to 2. So that is why the total number of functions in this case will be equal to 7c2 into 2. I hope you are clear with this. So what is this? This is 7 factorial divided by 2 factorial into 5 factorial into 2. This will cancel. And you can see this is 7 into 6. This is equal to 42. So there will be 42 functions which have range having 2 elements, and this condition is also satisfied. Now the last case. Now the last case says, third case. Range has 3 elements. Now we are considering range has 3 elements. Now if range has 3 elements, you can see this is pretty easy case. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So now for range to have 3 elements, we want 3 elements from this set B, right? So in how many ways? You can say 7c 3 ways. You can select any 3 elements from this. So let's say, for example, if I select 2, 3 and 4. If I select 2, 3, 4, now we have to map 1, 2, 3 under this condition. And again you can clearly see we have only one option, that 1 has to go to 2, 2 has to go to 3 and 3 has to go to 4. Right? We have to map all these 3 elements which you have selected, because we cannot map only to 2 elements, because that case we have already counted here. So we want to cover 3 elements in the range, right? So can we say there will be only one way to map these 3, 1, 2, 3 to these 3 elements 2, 3, 4. In any case you will have only one option. So total number of functions which satisfy the condition, the range has 3 elements, and this f of I is less than equal to f of j is 7c3. And you can check this. This is 7 factorial divided by 4 factorial, 3 factorial. You can see this is 7 into 5 into 6 divided by 6. This will be cancelled, and this is 35. So how many total number of functions we have? 7. Can we say this is 7 plus 35 plus what was the answer? Sorry, this was 42. So this is 40. So you can say what is the answer? This is 80. So total number of functions from A to B under this condition will be equal to 80. So I hope you have understood why we have taken 3 cases and how we got this total number of functions. Okay. So this concept is again very important, how to calculate different functions, number of functions in different cases. Okay. So I hope you have enjoyed this video also. So that's it for now. Thank you.